Welcome to Dr. Tarazi's Math Site. This video is one of a series covering the 2023 released Ohio State math questions. Recommendation:
To make the most of these videos, it is recommended to pause the video when you see this button, solve the problem, and then resume the video to check your answer.
Hello and welcome. An equation is given, a squared is equal to 36. What is a solution to the equation? Okay, so you put a squared equal to 36. Now you can square root both sides. Okay, then you get two solutions actually, plus or minus square root of 36 plus or minus 1. So if you answer 6 is fine, if you answer negative 6 is fine. So actually you are looking at a number. If you multiply it by itself, you get 36. Okay, that's very straightforward question. Which set of ordered pairs represent a function? So we have four things here. We need to see which one represent a function. Now remember, a function means for every input there is only one output. So let's check option A. Option A, 1 has output 1, 2 has a 5, and 2 has a 8. So that's not a function, okay? That's not a function. So you cancel this. The second one, negative 1 point to 2, 0 to 0, 1 to 2, 2 to 4, that's fine. See, none of this is repeated. None of this is repeated. So it is a function. So that's your answer. Now this one here again is not a function. Look, 1 is pointing to negative 2 and also is pointing to 4. So 1 has two images, that doesn't work, okay? And that one also, negative 1 has all these images, so that doesn't work either. A pebble weighs 3 times 10 to the power negative 2 pound. A large boulder weighs 9 times 10 to the power 3 pounds. How many times larger? Okay, so you have this information here, you have this here, and then how many times larger is the weight of the boulder than the weight of the pebble? Obviously, this is a division problem. Now, I put here for you a quick QR for a YTube video about arithmetic with scientific notation. It's good to go and check it out, maybe before even continuing with this video. So this is clearly a division problem. You divide 9 times 10 to the power 3 divided by 2 by 3 times 10 to the power negative 2. When you divide 9 divided by 3 is 3, and then this 10 to the power 3, 10 to the power negative 2, you get 10 to the power 3, and then you take this here and subtract it. You get 3 times 10 to the power 5 as an answer, or you can put it 300,000. A right rectangular prism is shown. This is an interesting question. What is the length of AB? What is the length of AB? Right means everything is 90 degrees, okay? So you have a 90 degrees here, you have a 90 degrees here, you have a 90 degrees here, 90 degrees here. Okay, so when you have this, you need to think of Pythagorean theorem. And I have here a link for a Pythagorean theorem YouTube that I recommend you watch. Pythagorean theorem always shows on the test. So what I'm going to do is I'm going to call this is C, this is D, and I'm going to make a line here. So I have a right triangle here, and I have going to make a line here. I have also a right triangle here. See, that's right. That ADB, ADB. And down here, the blue is also a right triangle. So these two are the same. AD, AD are the same. So if I can find AD, then I can find AB easily. AD I can find it using Pythagorean theorem on this triangle. Okay. So call this X. On this triangle now, X 4 squared plus 3 squared equal to x squared. 16 plus 9, 25 equal to x squared. So x is 5. So that's 5 and that's 5. Now I found x here 5. Now I have this is known. This is known. I can find a, b, apply Pythagorean theorem again. 5 squared plus 12 squared equal to z squared. 169 is equal to z squared. What number multiplied by itself gives you 169? It's 13. Okay. Christie drives from Columbus, Ohio to Cincinnati, Ohio. Match each graph to the quantity which would best represent the value of y with respect to time x in minutes during Christie's drive. So you have amount of gas in gas tank, distance from Cincinnati. Obviously, the distance from Cincinnati is going to be decreasing. Okay, getting closer to Cincinnati. Distance from Columbus is going to be increasing. Okay, you're traveling away from Columbus. So the first one here in the tank, so it's not, the amount is not increasing completely. Now here what happened is it came down and then you fill up gas and then go down again. Distance from Cincinnati, that's the best. Distance from Columbus is increasing, that's the best. Similar parallelograms EFGH and PQRS are shown, similar, okay? Which sequence of transformations can be performed on EFGH to prove that the parallelograms are similar? So here we have reflection across the x-axis, reflection across the x-axis, and then dilation by a scale factor of 3. Now, reflection rule is xy would be x minus y. X doesn't change. If you are reflecting across the x-axis, so if you have a point here, you look at the x-axis as a mirror, you get a point here. So x did not change, only y changed, okay? Now, if you are here, you want to go here, that's 6, that's minus 6. You go to this point here, that's reflection across the y-axis. See, x changes, but y does not change. These are the rules. So now the first one is a possibility. Now, there's a talk about rotation here, Students normally don't have really problem with dilation, reflection, translation. They have problem with rotation. So there's a video here that I made about rotation. So I recommend that you watch this video. So look at option B, a reflection across the x-axis. Yeah, we did reflection across the x-axis, but then dilation by a scale factor of 1/3. We are coming from this figure to this figure. We did not reduce it. We enlarged it. So that's not a possibility. Look at C. A 180 degrees clockwise rotation about the origin and then a dilation by a scale factor of 3. That is a possibility, so we come back to it, okay? Look at D. A 180 degrees clockwise rotation about the origin and then a dilation by a scale factor of 1/3. No, because we are coming from this to this. We're increasing it, so that's not an option either. So we have to discuss two possibilities, the option A and option C. Let's look at option A. Option A. Reflection across the x-axis. So only x does not change, only y changes, see? So you get this. Now, dilation by a scale factor of 3, so we're multiplying everything by 3. I get 3, -2, 3, -12. Okay, where is this? 3, see that this point here, 3, -12, yeah. -6, -12. Look at this point here, -6, -12, yeah. So that's the answer. If you want to check to make sure, let's check option D. So rotation about the origin, will give you this, okay? So all these signs changes, all rotation 180 degrees, okay? All of those changes, -1, -4, -2 becomes 2, okay? See? All changes. So now I got to this here, and now PQRS is this one here. Is there any dilation of 3? Did you multiply this by 3? Did you get this? No. Not a dilation. An equation is shown. How many solutions does the equation have? Okay, don't try to guess. Let's see. When there is no number here before the parentheses, you put a 1. Now we are going to use the property of distributive property, okay? Distributive property. Then you get negative times positive is negative, equal -3 times 4, -12, negative times negative is positive 9x. Combine like terms. So you have 9x here and 9x here. -7 is equal to -12, which is impossible. So we have to choose no solution. Quadrilaterals E, F, G, H, and E prime, F prime, G prime, H prime are shown on the coordinate grid. Which sequence of transformations shows that the quadrilaterals are congruent? Congruent means they are exactly the same, okay? So he's talking about reflect, translate, reflect, translate, again rotate, rotate, translate, translate, okay? Reflection, reflect, students normally really don't make mistakes on reflection and translation. They make mistakes on rotation. So again, I recommend that you watch the, see, like reflect, translate, reflect, translate, rotate, translate. So I recommend really before you do this to go again and see this video on rotation. It will help you quite a bit. So let's see, solution. We're talking about now option A, reflect EFGH across the y-axis. This is a reflection across the y-axis. Translate the image 5 units to the right. Then if I translate this 5 units to the right, I get here. So that's not a good answer. Let's look at B now. Reflect EFGH across the y-axis, again the same thing, and then translate the image 5 units down. If you take this 5 units down, this will not match this. Okay? That's not good. Rotate. Now we're going to be to rotate EFGH 90 degrees clockwise. I need to rotate this 90 degrees clockwise, so I'm going to be here about the origin, and then translate the image 5 units to the right. So let's see. That's also not good. See, if I rotate this 90 degrees, I get to here. Okay? And then translate the image 5 units to the right, go again here. That doesn't work either, okay? So now look at the last one. Rotate EFGH clockwise about the origin, and then translate the image 5 units down. Okay? So when you rotate clockwise 90 degrees, it's going to be here, and then translate the image 5 units down, go 5 units down, it matches 100%. Okay? So here's the calculation. Now, question number 25. Match the expressions in each row to the table to its equivalent. I don't know, what did I click on something here? There was something here that hidden maybe. Okay. Solution. Rules. X to the power m times x to the power n is equal x to the power m plus n. And x to the power m to the power n is x to the power mn. You need to remember these rules, okay? So now here, 6 times 3, 18. Good. Here, you add the exponents, you get 6 plus 3, you get 9. Quadrilateral ABCD is rotated about point P to create quadrilateral EFGH. Rotated about a point P, so I rotated this around. Select all meaning more than one option of the statement that correctly compare the two quadrilaterals. Okay, so what I can do is look at this small lady. This matches this. This matches this. This matches this. DC matches this. Now let's see. Is AB equal to EF? AB equals to EF? Yes. Is DA equals to GH? DA equals to GH? No. Is CD equals to FG? Is CD equals to FG? No. That's 4, that's 3, no. Is BC equals to FG? Is BC equals to FG? Yeah. Is CD equals to GH? CD equals to GH? Yeah, see? That's easy. When you mark them like that, it's really easy. Here, a linear model is drawn on a scatter plot as shown. What statement best describes how the linear model fits the data on the scatter plot? The model is bad fit for the data because many data points are below the line. I think that's the correct answer, right? Look at the other one. The model is bad fit for the data because the line only passes through 2 points. That has nothing to do with that, okay? The model is a good fit for the data because the line passes through some data. That's also not good. The model is good fit for the data because the slope of the line follows the trend of the data. That's not good either, okay?
Line of fit.
Here's a reminder. This is not good, bad fit. This is bad fit, many of them down, many of them up. This one is a good fit. See, some almost half up, almost half down, okay? Create an equation for the line that passes through 2, 5, and 3, 6. Through these 2 points, you need to create an equation. Okay, I'm going to call this one x1, y1, and this one x2, y2. I'm going to find the slope. y2 minus y1 over x2 minus x1. Delta y over delta x, sometimes they call it. You get 2 slope. Now you use one of these points to find the equation. Y-intercept formula is y equal mx plus b. Y equal 2x plus b, because the slope is 2. Now I need to find b. I use one of these points. So if I use the 2, 4 here, I put 2 times 2 and get 4 here. Then b is equal to 0. The equation is y equal 2x. Now once you get to this answer, you can check it. This is x times 2, you get 4. 3 times 2, you get 6. Yes, that's correct. Okay, now here. Rectangle ABCD is shown. Stella rotates ABCD 90 degrees counterclockwise around the origin. So this is going to end up being here, okay? Counterclockwise 90 degrees. Then she translates the rectangle to the right by k units to create rectangle WXYZ. One side of WXYZ lies on the y-axis. Again, you can check this rotation, a video. So rotates, translates. All right, let's see. First, we're going to rotate this 90 degrees counterclockwise. Is going to end up being here. here's the formula now for translation, for rotation 90 degrees clockwise. So y becomes negative y here, and change here, x stays the same. So here's my rotated rectangle. Now I need to shift this to the right k unit so that one of these edges is on the y-axis. So you can do y1 here, this becomes here, or you can do 1, 2, 3, 4, then a prime, b prime becomes here. So k is 1 or 4. A graph passes through the points 0, 0, 1, 2, and 2, 5. Which statement about the graph is true? It's linear because the graph passes through the origin. It's not linear because the graph passes through the origin. It's linear because a straight line can pass through the given points. It's not linear because a straight line cannot pass through the given origin, the given point. Solution. Let's look at A. It's linear because the graph passes through the origin. A graph can pass through the origin and yet it's not linear. Here's a graph that passed through the origin and it's not linear. So this has nothing to do with being linear. So you cancel this. It's not linear because the graph passes through the origin. Again, if the pass, that doesn't mean, here's a line that passes through the origin and it's still linear. So this is not good. It is linear because a straight line can pass through the given points. We need to check that now, okay? We need to check these two. So I'm plotting the points, and then if I draw a line now like this, it's not passing through the points, okay? It's not passing through the points. So it is a graph passes through the point, okay. So what do we have here? You can do that too. 3 over 1, the slope of this piece. The slope of this piece is 2 over 1. They're not the same. So it's linear because a straight line can pass through the point. The line does not pass through the points, okay? Straight line does not pass through the points. No, it is not linear because a straight line cannot pass through the given points. It's not linear. Okay, now, a scientist recorded the temperatures of 2 different liquids as they were heated. The results are shown in the table and graph. So sometimes they ask you to compare table and graphs. So here, starting point at 0, it's 18, the temperature. And then it started increasing, okay? Here at 0, the temperature is 20, okay? You have to understand how is this going, okay? So liquid 1 heated at a slower rate and liquid 2, a slower rate than liquid 2, and had a higher starting temperature. So let's put here. So let's do the, you're talking about this, he's talking about starting temperature and rate. Rate, starting temperature, rate, starting temperature. So I need to find the rate. So I'd make the differences here, 5, 5, 5, and here I have 17.5. The rate is 17.5 divided by 5 is 3.5. The rate here is, you take one point, you can take this point or this point. Point, it should be on the grid, okay? Or this point. So 60 over 18, the rate is 3.3 repeated. Now you see the rate of this one is higher than the rate of this one, and the starting point of this one is 0, smaller than the starting, 18 is smaller than the starting part of this one. Now you can choose here and find. The first one is not good. Liquid heated at a slower rate? No. Liquid 1 heated at a slower rate, you can say that too. Here, liquid 1 heated at a faster rate, that's good, it's a faster rate, this is bigger than this. And higher starting point, is this higher than this? No. So look at the last one now. Liquid 1 heated at a faster rate, correct, and had a lower starting temperature, 18, lower than 20. Mr. Miller presented his class with the following equation. What are possible values of P and Q? When he said possible values, you can have more than one answer. Again, here I have a QR for you to look at the arithmetic with scientific notation. It will help you quite a bit. So now, remember this rule. 10 to the power m times 10 to the power n is 10 to the power m plus n. So here, see this one? 7.5 times p is equal to 1.5, and I added here 4 plus q, the powers, is equal to 8. Then you have solved the system. You get p is equal to 0.2 and q is equal to 4. And you answer the question. Although it's level 3, but it's not really that complicated. So what I'm trying to do, these are coefficient here, try to match it with 1.5, and those are the powers, 10 to the power 4, 10 to the power q, 10 to the power 8, okay? Also, you can do this 1.5 times 10 to the power 8 is equal to 15 times 10 to the power 7. You put the equation now, and you get another question, another answer, 2, 3. So there is actually a whole bunch of possible answers to this question. This quick reminder, if you have a triangle like this, and this is the exterior angle, this here is equal to the sum of these two, okay? An exterior angle is equal to the sum of the two opposite interior angles. This is equal to the sum of these two, okay? And if you want the proof, it's right here, okay? Now, question number 40, that's why I don't want you to miss any of these easy questions. He's asking you create an equation for z in terms of x and y. So z is equal to x plus y right away. Z is an exterior, these two opposite interior angles, x plus y, okay? A convenience store has 20 bottles of water. Each day, a supplier delivers the same number of bottles to the store. The store does not sell any bottles of water for 3 days and now has 110 bottles. What is the rate of change in the store's supply of bottles of bottled water each day? Very simple. 120, 110, 110, and you subtract 20 from it, because now he has 110. We started with 20, so that will be 90 in 3 days. So 30 bottled water every day. 30 bottled water every day. Every time you can use a calculator, use the calculator. Match each expression to the range in which the value lies. Square root of 80, 85, 90. Using calculator, calculate square root of 80, you find this number, and that's between 8 and 9. Calculate square root of 85, you find this number, and that's between 9 and 10. Calculate square root of 90, you get this one, is between 9 and 10. So that's another question that you should not miss. Without calculator, you can say 80 between 64 and 81, perfect squares, okay? So square root of 80 is between square root of 64 and square root of 81, between 8 and 9. Same thing you do for 85. 85 is between 81 and 100. You get between 9 and 10. 90 between 81 and 100, between 9 and 10. A cylinder is shown. What is the volume in cubic meters of the cylinder? The volume here is the base times the height, base times the height, and base happens to be a circle, okay? So base times height of pi r squared times h. Now, r is that's a diameter. That's the mistake student will make. This is, you don't use the 6, you have to use 3, half of it. So pi, okay, you get 90 pi cubic meters. So the answer is 90. If you use 6, here's what happened. You get 360 and you think that you found the answer. It's incorrect, okay? So be careful about that. Be careful. Many students make this mistake. A teacher compares the masses of 2 samples of different liquids. The equation M is equal to 0.674 V models the mass M in grams G of liquid ammonia. The variable V is the volume in milliliters. The graph shown represent the relationship between mass and volume for hydrogen peroxide. Okay? I have to understand those things here. The teacher compares the masses of 10 milliliter sample of each liquid. So X is 10 in each liquid, okay? The mass, M is 10, okay? M is 10. Yeah, that's the volume mass. So he used the masses of 10 milliliter, compared the masses of 10 milliliter. 10 milliliter, those are the volume, okay? Sample. Select words or phrases to complete the statement to describe which sample of liquid has a greater mass. Okay. So, let's see, solution 1. Ammonia. M is here. So the volume, this is the volume, okay? That's the volume. 10. You get the mass would be 6.74. Hydrogen peroxide. M is equal to 1V. Why? When V is 10, M is almost 10, see? When V is 10, M is almost 10. So now what do we have? The sample of hydrogen peroxide has a greater mass because it has the greater unit rate. Greater unit rate. Okay. The graph shows the relationship between the number of computers sold and the number of printers sold at different electronic stores in a city. Number of computers, number of printers. Okay. What type of association best describes the relationship between the number of computers sold and the number of printers sold? Now, you need to kind of remember something. If you have something like that, that is a linear association. If you have something like that, that's a linear association. This one here is positive association. This one here is negative association. If you have something like that, that's nonlinear and positive. If you have it something like that, that's nonlinear and negative. Okay? So let's see. This one here is linear and positive. So that's not good. Non-negative linear, that's not negative, that's positive, that doesn't work. Positive linear association, yes. No association, when you have something like that, you have no association, okay?
Thank you and see you soon.
Thank you for watching. More videos to come. Please subscribe.